Hello. Hi. This is Miss Car, and welcome to Learning Physics. So now we're going to have our practice solving on conservation of energy. So in the conservation of energy, we are going to apply the things that we have studied on the calculations of kinetic and potential energy using our basic equations. Okay, so if you can still remember last time, di ba, I allowed you to have a copy or have a screenshot of the problem solving. So now, ang amo to siya nga mga problem solving, i-answeran na naton one by one. So to start with, let us have here our first problem. So a 17 Newton is applied to a 10 kilogram block at rest for a displacement of 200 meters across the frictionless surface. So letter A, how much is work done? Or how much work is done? Sorry, balis ka dahan ninis. Next, what is the acceleration of the block in the horizontal direction? And letter C, use kinematic equation to calculate the final velocity. Letter D, what is the final kinetic energy? And lastly, how much is the kinetic energy? So let us try to answer our first problem by listing down first the following given. So for our given here, we have the force that is 70 newtons. And then the mass that is 10 kilograms. And of course, we have there the D or the distance that is 200 meters. Now for letter A, we're going to solve for the amount of work done. So, if you can still remember, our equation for work is equal to FD or work is equal to MAD. Okay, so may duwa kita ka formula. Okay, now by taking a look here on our given, ang given dira naton is the force and the distance and the mass. So, in our equation here, by looking for the amount of work, the best equation for us to use is the work is equal to FD. Nga kay ara na si force and ara na si distance. And also, kung gamiton ta ni ang ating second equation, wala kita dira sa acceleration. Okay, so let us try to solve for work using our first equation. So substitute the values in the equation. So we have 70 newtons times 200 meters. So 70 times 200 is equal to 14,000 Newton meter or 14,000 joules. So this is now for work. That's for letter A. Okay, so now that we're done for letter A, we can now solve for our letter B. For the letter B, for letter B, let us solve for the acceleration. So how can we solve for the acceleration? Ayan, butang na siya ninis para medyo kitaon. Okay. So, of course, we have two equations for the acceleration. So, we have here the F is equal to ma and A is equal to velocity divided by time. Now, going back to our set of given, we have here the force, mass, and the distance. Okay, so for us to solve for the acceleration, mapili man naman kita diri. Diin sa duwa ka equation ang may ara sa present nga ara sa given nga values. Okay, so may ari kita diri force and mass. So, in the given, wala kita sang velocity, meaning hindi ta ni siya paggamiton. Gamiton ta is the F is equal to ma. So, let us use that, and after that, substitute the given in the equation. Okay, so 17 newtons for the force is equal to, for the mass, that's 10 kilograms. Times the acceleration. Okay, So, para makuha ta si acceleration, we are going to divide both sides by 10 kilograms. But then, take note, kilograms and newtons ang aton unit. So, in order for us to, of course, cancel the units, we have to extract the unit of newton. So, bukadon ta siya danay. So, let us have here 70 kilograms meters per second squared is equal to 10 kilogram times the acceleration. And after that, divide both sides by 10 kilograms. Cancel, cancel. Cancel si kilograms. Okay, so dili butang ni Miss, mabutang si Miss Arrow. So for A, 10 divide 10, cancel, A na lang ang bilin. Okay, so we have here 70 divide 10. 70 divide 10, we have there 7 meters per second squared. So I hope that it's just clear. I hope na naintindihan lang kung paano siya suma. Okay, so that's for letter A and letter B. Okay, now let us try now to solve for our third unknown value. For letter C, we have there use kinematic equation to calculate the final velocity. Now, we have different ways of calculating the final velocity. We can use different equations. However, it is specified in the problem wherein we are going to use the kinematic equation. So, before kita magsuma sa VF, let us recall first what are the different kinematic equations that we used last time. Okay, so here are the different kinematic equations. By the way, sulatan ni Miss V sub F. Okay, that's question 1. Okay, so pangitaon ta sila using kinematic equation. So, list ta danay, VF is equal to VI plus AT. Then, D is equal to VI plus VF. Divide 2 multiplied by T. Also, we have D is equal to VIT plus 1/2 AT squared. And lastly, we have VF squared is equal to VI squared plus 2AB. So, sila na ang aton nga gamiton nga equation. Okay. Now, by the way, let us list down kagina kung ano tong mga values yung calculate naton. So, work to kagina is 14,000 joules. And ang aton nga acceleration, it is 7 meters per second squared. Okay. Now, in solving for the velocity, of course, lantawon ta ang aton given kung masanto man siya sa aton gamiton nga equation. Now, on the first equation that we have here, we have VF equal to VI plus AT. So, we have here the acceleration. We have here the, however, we don't have here the value of time. Okay, so since pagkakita natin sa value of time diri, cancel ta na siya dayon. Okay, so how about the initial velocity? Okay, let us go back there to our problem. Sorry, medyo gasilaw siya. Let us go back there to our problem. So according to the problem, ang block kuno is at rest. Okay, so since at rest siya, meaning ang iyang first velocity or ang iyang initial velocity there will be equal to 0. So, amo na siya, pangitaon ta ang final. Okay. So, now may ara na kita value sa VF. Okay. But then again, kulang man tagyapon time. So, meaning cancel niya siya nga unit. On the second equation, may D kita, yes. May VI kita. Pangitaon ta si VF, however, kakson ta naman wala ta kita time. So, cancel na siya. So, on this equation, present ang tanan, except man kay time. And wala kita diri sa VF variable. So, meaning hindi na siya gamiton. So, the best equation to use is the fourth equation. So, let us now use our fourth equation for our final velocity. So, here, let us directly substitute na lang. Kay total, amo na ni siyang equation na gamiton ta. Ma-direct substitution na kita sa aton nga values in the equation. So, Vf squared is equal to, take note that your V sub I is equal to 0. Okay? So, meaning i-cancel na siya, 0 na siya. May mo na lang siya, 2AD. Okay. Now, solve na kita sa aton yung final velocity. So, Vf squared is equal to 2 times velocity acceleration, that's 7 meters per second squared, times the d, that is 200 meters. Just simply multiply lang. So, Vf squared is equal to, let's multiply 2 times 7 times 200. And that's 2,800. 2,800 meters times meters, that's meters squared per second squared. Now, naka-square si variable, at the same time, naka-square ang units. So, we're going to square root both sides. So, cancel, 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 cancel. So, we have there, square root of 2,800 is equal to, let's take a look kung pilang value. That's Vf ni siya naton. That's 52.92. What's the unit? Meters per second. So this is now for our final velocity. And that is using our kinematic equations. Okay? Kinematic equation. Nanggalit kay isa lang siya. Okay, so that's for letter C. Now for letter D, let us solve for the final kinetic energy. So how can we solve for the final kinetic energy? Okay, so here it is. So if you can still remember, may ara kata diba sang change in kinetic energy. So nato siya gani ini sang change in kinetic energy. Change in kinetic energy is equal to the final kinetic minus initial kinetic energy. Okay, so amo na siya ang aton nga gamiton. Okay, let us solve for letter D. Letter D. We're going to solve for the KE final. So, paano ta na siya mabalaan? Okay. So, change in KE is equal to KE final minus KE initial. KE initial. Okay. Now, take note nga kung bukadon tani sila, we have here change in KE. Makita niyo sa, so ano gani ang aton equation for kinetic energy? It's 1/2 mv squared. So on this case here, so si KE final kung bukadon ta na siya, we can have your 1/2 mvf squared plus 1/2 mvi squared. Sorry, it's minus. Minus na siya. Okay. So, there. Now, take note nga aton initial velocity is 0, meaning cancel na si KE initial. So, how can we determine the change in KE? So, let us have here. How can we determine gali ang aton nga KE final? So, magkuha kita sa KE final. Amo na ni siya nga danay nga equation na aton gamiton. Miss, may question ko. Nga diri lang ko danay ma-focus. It's because pangitaon talang danay si KE final. So in order for us to look for the KE final, gamiton ta si 1/2 mvf squared. Now let us solve for our KE final using here our equation. So KE final is equal to 1/2, substitute the mass, that's 10 kilograms, times, pila gani ang aton nga VF, ito gani naton VF, butang niyo sa, kung nadumdum, it's 52.92 meters per second. Okay, so i-substitute tala na siya, 52.92 meters per second. Substitute, just simply multiply. I-square na siya gali. Okay, so we have here, so KE final, we have 1/2. Copy talang danay ha, okay? Times 10 kilograms. I-square to si 52.92. So, 52.92 square is equal to 2800.53. Okay, so we have 28,000, 2,800, sorry, 0.53 meters squared per second squared. Okay, so we'll just simply multiply the values. 10 times 2,800.53 is equal, here's the value, and then divide it by 2. So we have 14,000.65. 14,000.65 kilogram meter squared per second squared, or also we can have 14,000.65 joules. That's for our KE final. Again, this is for our final kinetic energy. So I hope that it's clear. Okay. So I hope that's just clear. Ayan. So move na si Miss. Okay. So this is for our letter D. Now, for our letter E, we are going to look for the change in kinetic energy. Now, let us go back here to our equation diri sa babaw. So, kagina, gin-cancel ta na si KE initial, that's equal to 0. Now, based here on our equation, we have the change in KE now, which is equal to 1/2 mv squared. Or therefore, we can say that since cancel na ang initial velocity, therefore, we can say nga si KE final will be now equal to the KE initial. So, in this case, our letter E, for letter E, dinilibis butang, diri. Okay, so for letter E, medyo gutok siya. Okay, here. For letter E, ayan. Our change in KE is equal to KEF. Okay. So, since nag-amuna siya, nag-amuna siya gani, kay tungod sa amunin natin yung equation kagina. So, if KE final is equal to 14,000.65 joules, therefore, change in KE is equal man to 14,000.65 joules. Okay, so this is it for letter E. So I hope that is just clear. Okay, so let me tell you something. Now, if you can still remember kagina, our total work nga ginhimo or ang aton nga work done is 14,000 joules. Okay. Now, so si work done nga dira kagina nga ginasuman naton is the total amount of work. Now, if we're going to take a look here on our change in KE, so si change in KE if you can still remember, work is equal to change in KE. Kung nadumduman pa na siyang ginhambal last time. So, kung pila ang aton nga change in KE, kinahanglan mapariho man na siya sa aton nga amount of work done. If we're going to take a look, si KE naton kag si work has the same value. However, may gamay lang tanga discrepancy, but it's fine. Still, if you're going to take a look, we have the same value. So therefore, we can say that tsakto ginman gali means nga work is also equal to change in kinetic energy. So I hope that it's just clear. Okay. So that's for our first problem. Now let us try to solve here our second problem. For the second problem, a 2-gram stone is thrown upward with a speed of 0.25 meters per second. So first, we are going to determine the total energy of the stone. Second, how much is the potential energy when it reached the maximum height? Third, how tall did the stone reach as it was thrown up? Okay, so let us solve for each of the following unknown value using our, of course, equations, and also, of course, by listing the following unknown or the following given in the problem. Sorry. Okay, so adjust muna ng gamay si Miss para ma-plaster. So we have here the given. Let us list down the given first. Where's my magical marker? It's lost. Is it lost? Okay. Ika lang ha. Ito marker ni Miss Man. Dulaaw. So given. I have something. Okay, so naman kapasabat kay Miss Man. Okay, so given naton. Sorry, class, nangita pa ko sa akong na marker. So given, we have here the mass. That's 2 grams. And then we have the speed that is 0.25 meters per second squared. Take note nga si grams si mass gali naka grams. So para karon transform ta siya into joules, knowing mangita kita sang energy. So we have to convert grams into kilograms. So butang na din is ang simple conversion. So we have here 1,000 grams is equal to 1 kilogram. So we have here 2,000 2 divide 1,000. Okay, 2 divide 1,000, that's equal to, let me take a look here, that's 2 times 10 to the negative 3, or we can have here 2, butang din isa, kilograms, or, butang din is or, 0.002 kilograms. Okay. So, pwede sila nga duwa. Depende kung sino imo gamiton. Okay. So, we are going to look for the total energy. So, how can we determine the total energy? Okay. Take note nga si total energy. Kung madumduman nyo pa, the total energy is equal to KE plus PE. Kung nadumduman na siya. Okay. So, kapag kamita kita gan isang total energy, knowing nga, ang aton diri nga given is mass and velocity, mabalik kita sa aton yung mga equation. Isa-isahon ta ni sila. So, KE is equal to 1/2 mv squared. And then, PE is equal to mgh. Okay, so butang tada GPE para to be specific lang. Ang EPE is equals to 1/2 kd squared. So, kung lantawon ta sa ilang nga tatlo, sinuda nga energy ang gina-refer naton. So, meaning, si kinetic energy nga kay ari siya sa may ara siya mass and may ara siya velocity. Okay. So, meaning, wala ni sila nga duwa. Hindi na sila gawaga Newton. Okay. Now, take note nga total energy. So, with that total energy, 1/2 mv squared, meaning total kinetic energy danay ang aton pangitaon. Kay kung pila ang aton nga total kinetic, same man na siya sa aton nga total nga energy gid. Okay, so we have here, so let me have it here first here. So total, para clear is equal to KE total. Amo na siya. Para maintindihan nyo man. Okay? So, ayan. So, let us try to solve for our total energy. So, we have here KE is equal to 1/2 mv squared. So, substitute lang 1/2 times the mass, that is 0.002 kilograms, times the V, that is 0.25 meters per second. Per second, and then square. So, ayan. Nagsala si Miss. Okay, then substitute lang. So, we have here 1/2 times 0.002 kilograms square kasi 0.25. 0.25 square. And that's equal to 0.63. Okay? 0.063 meter square per second square. Okay, so multiply ta sila nga tatlo. So we have 0.002 times 0.063. Okay. So let us have there. Oh, sorry. Divide pa siya natin kay 2. Divide the answer kay 2. That's equal to, ayan, 6.3 times 10 to the negative 5 kilogram meter square per second square, or equal to 6.3 times 10 to the negative 5 joules. So this is for our KE. What is this KE? This is the KE total. Now the question is, pila ang aton nga total energy? For our total energy, so let us have here, so total energy is equal to total kinetic energy. So if KE total is 6.3 times 10 to the negative 5 joules, therefore, total energy is also equal to 6.3 times 10 to the negative 5 joules. Okay, so there it is. This is for our calculation. So I hope that is just clear. Okay, so that's for our first unknown value. Okay, now let us try to solve for our second unknown value naman. Okay, for our second unknown value, okay, so diba throw ang object upward. Okay, so throw siya upward. So if this is the stone, para siya throw siya upward. Ayan. So ang iya nga KE total na, ang nga KE is equal to 6.3. 6.3. Now the question is, pila ang iya nga potential energy sang na-reach ang maximum height? KE total. So na-reach ang maximum height. So di ba hambali miss, basta gani maximum height meaning PE total na da siya ang ginahatag sa aton. This is for number 1. Now for number 2, there's no need for you to calculate. Instead, kinanglan mo lang siya i-analyze. So as the stone reach the maximum height, the kinetic energy will be lost and the potential energy will gain. So meaning the transfer or the lost kinetic will be transferred to our potential energy. So for number 2, so KE total is equal to PE total. So if KE total is equal to 6.3 times 10 to the negative 5 joules, therefore, sige, diri si mismo butang sa dalom. Here, therefore, PE total is equal to 6.3 times 10 to the negative 5 joules. So, amo man siya gyapon. Kaya nga, nag-refer na kita sa total. So, meaning ang total energy niya ina is the same with the total KE was the same with the total PE and also the same with the total gid niya energy. Okay. So, tandaan lang kung ari sa dalom, ang PE ta is 0. Kabay pa nga madumduman nyo to siya sa nigad. Ang ginaton nga discuss, right? Ayan. So, always remember that. So, if you want to make some proof kung sakto or not, so you can use the total energy is equal to KE plus PE na equation. Don't worry because later on we're going to use it as we have our other calculations. Okay, so that's it. Now, that's for our first and second unknown value. Now, for our third value, let us try to solve for it. So, how tall did the stone reach as it was thrown up? So, we're going to determine kung how high ang ginlabot sang stone paghaboy sa iya. Now, let me just erase first here the calculations for KE. Muna na siya dali ang ipanaso ni Miss para kitaon padi ang aton nga values. Okay. Okay. So, pangitaon ta ang height. So, PE, let's be specific. Kay tungod, throw ang object upward. So, meaning, ang PE, ang ginapangateta is the gravitational potential energy kanina. Ayan. So, meaning, gamiton ta ding equation. So, GPE is equal to mgh. Okay. So, since it involves, of course, vertical motion, therefore, we are going to use our G value, and that is 9.8 meters per second squared. So, pangitaon ta ang aton nga height. So, pila ka gani aton PE? This is 6.3. Ay siyang PE total taho. 6.3 times 10 to the negative 5. So, 6.3 times 10 to the negative 5 joules is equal to the mass. That is 0. This is the mass, 0.002 kilograms times 9.8 meters per second squared times, of course, the height, which is the unknown. So, multiply ta lang sila nga, uwa, and extract ta lang ang aton unit diri. So, we have here 6.3 times 10 to the negative 5th Newton meter. Nga ang Newton meter, o, pakita na later ni Miss. So, i-multiply tang duwa ka value. So, we have here 0.002 times 9.8. That is equal to, so we are going to use here 0.020 kilogram meter per second square is equal to Newton times the height, which is the unknown. Now, divide both sides by 0.02. 0.020 newtons. 0.020 newtons. Cancel, cancel. We have here the height. Newtons naton, cancel. Okay, let us encode our values in the calculator. Times 10. Times 10 to the negative 5th. To the negative 5th. Okay, so let me have here first the parenthesis. Sorry, I forgot to write the parenthesis. Kinahanglan naka-parenthesis gid ha. Basta naga-divide value nga may nga may naka-scientific notation kay para hindi mabudlay yan sa answer. 0.020. Ayan. Okay, so that's our answer. For the height, it's 3.15 times 10 to the negative 3 meters. So, medyo iusog siya ni Miss. Ginilikin ko. 3.15 times 10 to the negative 3 meters. So, this is now for the height sang object. So, meaning mabuo ng gid siya or ano man gid, anong natabo. Okay. So, here it is for our value. Okay, so that's for our second problem. Okay. Now, let us have here, since we're done with the second problem, of course, let us have now our next problem. Okay. So, we are almost there. So, for our third problem, sa atong third problem, so the spring exerted 45 Newton force in 5 meters. Okay. So, letter A, for the first unknown gali, so how much is the spring constant of the spring, of course. So, if the spring has been stretched and released with a work of 150 joules, how much is the kinetic energy released? And how far is the spring stretched? Okay. So, let us try to solve na naman sa aton nga unknown values on the third problem. Okay, so here, let us list down the given. So, we have there the force that is 45 newtons And then 5 meters for the distance. For letter A, pangitaon ta ang ato nga spring constant. So, in looking for the spring constant, we can use our equation. K is equal to F over D. D gali. B man niya kay Miss Man. Sorry. D. So, we just simply substitute the value. So, for the force, pilaton force, that's 45 newtons divide 5 meters. Wow. So, 45 divide 5 is equal to 9 Newton per meter. And this is now our spring constant. Okay? Diba? Hapos lang siya. Spring constant. Okay? So, we have here, in terms of Newton per meter. Tandaan gina siya. Okay. So, next, let us solve for our second unknown value. If the spring has been stretched and released with a work of 150 joules, how much is the kinetic energy released? Okay, so mabutang ko dis ang aton nga spring. So, let's say this is our spring. Okay, this is unstretched. So, let's say gin-stretch ang aton nga spring. Ar na siya ang aton nga stretch nga spring. Okay. Here. Okay. Now, the question is, let's say ang force na pagbutong natin, this is the equilibrium, the unstretched part. Ang aton diri nga force, exert mo para ma-stretch mo siya, ang force, gamit mo, pakatuda siya, is equal to 45 newtons. And the distance is, of course, equal to 5 meters. Now, take note, halin diri sa equilibrium, so ari pa siya, iya nga potential, ang iya nga potential energy is equal to 0. Nga equal to 0, kay wala pa siya magin himo nga distance. Pero, kay tungod 0 iya PE, may value ginadiri ang iya nga KE. Diba? Igabilis ka danay da sila, KE may value. Okay. Sang stretch siya, of course, may value na diri ang aton nga PE. Nagka-value ang aton nga PE. So, ano na siya nga PE ang ginanamin ta dira? Ang aton nga EPE or the elastic potential energy. Okay. So, wala ti kita kabalo kung pila ang iya nga value sang pag-stretch sa iya. But then sa problem ginapamangkot, pila ang iya nga energy or ang iya nga kinetic energy pag-release. So in looking for the kinetic energy, we need to use our equation 1/2 mv squared. Kung madumduman, kay kinetic energy, kinahanglan ta magamit 1/2 mv squared. But then, we cannot see the value here. The values sang mass and the velocity. So ano ang himuon ta para makakita kita sang value sina? Take note, we have the conservation of energy from kinetic to elastic potential. So in order for us to get the value of the kinetic energy, we need to look first for the value of the elastic potential energy. So gamiton ta ang EPE equation naton. So butang ko diha, KE pangitaon ta, pero mangita kita first sang EPE. So, paano ta pangitaon si EPE? Let us use our EPE equals to 1/2 KD squared. Okay. So, we have now here the value of K. May ara naman kita value sang D. Okay. So, substitute lang 1/2 times 9 Newton per meter times the D that is 5 meters, then square. So, we have 1/2 times 9 Newton per meter. So, 5 squared, that is 25 meter squared. Just simply multiply the two values, then divide by 2. So, we have here 9 times 25 is equal to 225 divide 2. That's equal to 112.5. So, we have 112.5 Newton. Cancel ang isa ka meter sa dalom denominator kag buhini ang duwa isa. Newton times meter. So for our EPE, we have 112.5 EPE joules. Okay. Nakita ta na kung pila ang iya nga maximum EPE pag stretch mo sa iya. Now, how about if i-release mo na ang imong spring? Okay, so this is for the EPE pag stretch mo. Now, pila ang iya nga EPE or ang iya nga energy, sorry, pila ay haning iyang energy pag release mo. The maximum EPE, the EPE maximum is equal to your KE maximum. Take note of that. So, halin diri pag-release mo, ang iya nga potential energy will be gradually transferred to kinetic energy. So, if EPE maximum is equal to KE maximum, and if EPE maximum is equal to 112.5 joules, therefore, KE mo dira, ang imo nga kinetic energy would be, pag-release mo na, would be equal to 112.5 joules. Parihas na sila nga duwa. Nga aging butang ni Miss Maximum, kay tungod ara siya sa pag-stretch gid, and then, pag-release niya, nagbalik siya sa iya nga equilibrium. So, amo ni siyang iya nga maximum naman na siya ang ginahatag dira sa imo. So, I hope that it's clear na. Okay. So, there. So, for so that's for our second unknown. So, for our third unknown, how far is the spring stretched? So, take note that there are some problems wherein ginapatalang-talang na kamo na ginapaminsar kamo ay hala kinahanglan ko pa ni siya i-solve or not. But then there is some unknown value or mga pamangkot sa problem wherein ara na sa tubangan mo tok-on ka na lang, just like here in our third question. So how far is the spring stretched? So as what is already presented in the problem, it is stretched 5 meters. Okay. So for for our third unknown, let's say, let me have here letter C. So it is 5 meters. Ara na siya sa problem, oh. Lantawon mo na lang, tukon niya na lang kana, kinahanglan ka balo ka gid mag lantaw permis ang imo nga values nga sa problem. Okay. Now that's for our third problem. Okay, so I hope na nag-gets lang gid. Okay. So now, for our last problem, let us have it here. Okay, so you are on a roller coaster. You are on a rollerblades on top of a hill. Your potential energy is 1,000 joules. And the last time you checked, your mass was 60 kilograms. Now, the question there is, what is your weight in newtons? Kadumdum pa ka mo magkuha sang weight. Okay, so next, what is the height of the hill? And lastly, you start skating down this hill, your potential energy will be converted to kinetic energy. So at the bottom of the hill, your kinetic energy will be equal to your potential energy at the top. So what will be your speed at the bottom of the hill? So diba, speed ang pangitaon ta on our last unknown value. Okay, so let us try to solve for each values there. Okay. So, here. Let us list down here the following given in the problem. Okay, so here you are on a roller blades. Now, according to the problem, the potential energy is, your potential energy at the top is 1,000 joules. Okay, and your mass is 60 kilograms. Okay, now for letter A, what is your weight in newton? Ano gani magkuha sang weight? Weight gali weight. So, himuon ni Miss kay since force ni siya, himuon ni Miss F sub W. Weight na siya ha, weight. Okay, is equal to mg. Please don't be confused. Si gravitational force, the same na siya kung paano ka magkuha sang weight. Again, please don't be confused. So, recall lang kung ano to siyang gintunan natin kay forces. Ayan. Okay. So, to solve for your weight, of course, just simply multiply 60 kilograms times your mass. Sorry, we have there the G. Sorry, I forgot to write our constant. 9.8 meters per second squared. Okay, so there 9.8 meters per second squared. Okay, sorry, nalipat si Miss ha, pero amo na siya. Okay. So, just simply multiply. We have 60 times 9.8. Okay, that's 588. 588 kilogram meter per second squared or equal to 588 newtons. This is for your weight. Okay, may weight ka na. Mukha nakabugat sa Earth. Okay, so 588 newtons. That's for our first unknown. So for our second unknown, what is the height of the hill? So how can we determine the height? Letter B. How can we determine the height of the hill? So take note, kung pangitaon ta ang height sang hill, di ba? Nagaamo ka na ho? May ara kita sa vertical motion involved. So, since may vertical motion involved ta, meaning, pangitaon ta dira, gamiton ta nga equation da. And since going gali sa aton nga given, may ara kita potential energy. So, meaning, gamiton ta nga aton nga GPE equation kay para makitaan ta or ma-determine ta ang height sang hill. Kay again, para kay nga aga gamiton ta si GPE kay may vertical nga motion involved. Okay, so wala man kita naggamit string or any stretch and compressed object. Nga nag-stretch and nag-compress na object. So that's why GPE atong gamiton, not the EPE. So GPE is equal to mgh. Ayan, so muna siyang aton nga gamiton nga equation. Okay, now for our PE, may ayan kita value, that's 1,000 joules, equal to the mass. Your mass is 60 kilograms, and the gravitational acceleration, that's 9.8 meters per second squared, times your height. Okay, just simply multiply, and later on, ang kaksunta na sila isa-isa. Now, kung lantawan ta, ang 60 times 9.8 ang ginhimo naton si M kag si G, magkuha ka sang weight, S, ginmultiply mo lang sila nga duwa. Okay, now, take note nga ang imong weight is also a force. Okay? Force man na siya nimo, your gravitational force. Amo siyang gina-exert mo. Now, in our equation here, kung tawon mo, you have now the value, you have here the variables m and g, and i-multiply naman siya. So, meaning, kung pilang imo nga weight, same man siya sa value sa ating na mg man diri nga sa equation. So, we have here 588 kilogram meter per second squared, that is equal to newtons times height. Okay. So, para ma-cancel ta ang units, ang joules naton himunta siya newton meter. Divide both sides by 588 newtons. Cancel the units. Okay. So, what will happen? So, our height here, bilin nga, unit, a variable rather, and then 1,000 divide 588. There. That's equal to 1.70. 1.70 meters. So, meaning ang height sang hill, nga, sang small hill nga gin, skatean mo is 1.70 meters. Okay. So, muna siya ka taas. Okay. Next. So, on the third unknown value, it is stated there that your potential will be converted to into kinetic energy if mag-start ka na panaog sa hill. Okay, so at the bottom of the hill, your kinetic energy will be equal to your energy at the top. So pila gani ang aton energy at the top? PE is equal to 1,000 joules. So, this is at the top pa lang siya. So, manaog ka, this is the hill. Okay, so kung manaog ka, ang imong KE, PE mo na dara. Ara siya. Sorry. Ara ka sa hill ha. Ara ka sa hill. Okay, so amo na siyang imo nga PE sa top. Tapos, pila na daw ang imo nga KE, ma-equal na siya kay 0. So, samtang pamanaog ka, until such time nga ara ka na sa bottom sang hill, ang imo nga PE will be gradually converted to KE. So, it will become 1,000 joules naman. Okay, so what will happen to your PE? It will become equal to 0. So, pila ang imo nga KE dira? Again, that's 1,000 joules. But then, for letter C, pangitaon mo is the velocity. So, since kabalo ka na sa imo KE at the bottom, you can now determine kung pila ang iyang velocity sa bottom or samtang nagakapanaog na siya sa hill until it reach the bottom. So, amo ni siya nga value ang gamiton ta, and we're going to use our KE is equal to 1/2 mv squared nga equation para makuha taman ng aton nga velocity. Okay, so before we solve for the velocity, let me just rewrite here our equation. Okay, para klaro sa aton tanan. So for letter C, V is the unknown. Okay, so panaso na ni siya. So let us use KE is equal to 1/2 mv squared. Okay, so since we have here the KE, substitute na lang. 1,000 joules is equal to 1/2 times your mass, that's 60 kilograms, times V squared. Okay, so 1,000 joules. Take note, naka-kilogram siya. So, ibu-count ang joules na may kilogram man. That's kilogram, meter square per second square equal to 1/2. 60 divided 2. That's 30 kilograms. Ayan. Times V squared. Divide both sides by 30 kilograms. 30 kilograms. Cancel. We have your V squared. Cancel the units. So 1,000 divide 30. 1,000 divide 30. That's equal to 33.3. 33.3 meters square per second square. Square root both sides. Kinaka-square pang variable kag ang unit. Okay? Square root of 33.3 is equal to 5.77. 5.77 meters per second ang velocity samtang papanaog ka sa hill. So here it is. This is for our last unknown value. Okay, so that's all for our practice solving using our equations, of course, in kinetic and potential energy. And also, you can see kung paano man mag-relate si kinetic energy, potential energy, and the total energy at the same time to work to each other. So I hope that you just understand on how to calculate kung paano mag-understand man nga magkuha ka sang one value to mag-relate ka gila isang one value to another. So I hope that this practice solving also will help you in the preparation of our upcoming exam. Okay, so thank you so much for listening. Thank you so much for taking the time to study our practice solving, and God bless you all. Good luck to your examinations. Bye!